A complex fraction is a fraction in a fraction.
Oh, God.
So, if you think about it, it's really not that bad. It's just, it looks worse than it is. If you have something like 1/2 divided by 2/3, okay, that's a complex, right? That's a fraction in a fraction. What would you do there? That's exactly what I would do. I would rewrite it. Instead of writing it as a fraction, I would write it as a division problem. And I would say, well, wait, that's the same thing as 1/2 divided by 2/3. And I can change division to multiplication and flip that second one. And then it becomes a multiplication problem, which I'm good at, right? I hope you're good at, right? So it's just top times top and bottom times bottom. So what we're going to do, I do these in columns because the top, we might have to add or subtract in the top, add or subtract in the bottom, and then put them together. So let me show you what these look like. Today's the 7th, May the 7th. Let's say I have, thank you, 3 over x plus 2 plus 2/3. And that's going to go over 2x over x plus 2 minus 1 over x. Again, I just have to remember this is a division problem, yeah. So what I generally do is I make 3 columns, and I'll do, so this is my problem. I'll say, okay, if I simplify the top, what is it going to look like? So in other words, we're just going to kind of chunk the problem. Just the top is 3 over x plus 2 plus 2/3. Are we all in agreement there? In order to add, I need to have a what? Common denominator. So what's my LCD here? 3x plus 2. So the first one needs a, and the second one needs a x plus 2. So this becomes 9 plus 2x plus 4 over that LCD. This is the same thing we've been doing for a couple of days, right? And they're actually a little bit easier, I think, most time whenever you get them in a complex fraction. All right, so I have 2x plus 13 over 3 times x plus 2. Can anything be factored any further there? No, right? You can't take anything out of the top. It's not a quadratic. So that is my simplified top. Does that make sense?
Yes.
Okay. Let's look at the bottom then. So I'm going to do now the bottom. I have 2x over x plus 2 minus 1 over x. Does that confuse anybody? All right, so what's my LCD? X plus 2. The 13? You sure? You back on the top over here? You see it, 9 and 4. All right, what's the first one need? X. What's the second one need? X plus 2. Careful of the subtraction sign here. So I get 2x squared minus, and I'm distributing -1 through there, so minus x minus 2 over the LCD. Can that be factored? Does anything multiply to -4x squared but add to -1? No. So this one is simplified. Anybody confused? So here's the new part, yeah.
Instead of distributing the negative, can you just calculate and do the same thing?
Yeah, sure. Sure. All right, then let's put them together. Man, I'm at the bottom. That's okay. Do a different color. I thought I had scrolled up, but I hadn't. All right, so together. So remember what we're going to do here. We're going to make this a multiplication problem. We're going to take the top. And we're going to multiply it by the flip of the bottom. So we got to flip this bottom around. So x times x plus 2 And everything's been completely factored, and I'm multiplying, and this is where if you mess up, this is probably where you're going to mess up. You're going to try to make it harder than it is. Every single plus or minus is enclosed in parentheses, right? I can start canceling at this point. I don't have to multiply out, distribute, simplify that down. It's already done that. So what I want to do is just start canceling. Do you see anything that cancels? X plus 2? Is that it?
Yeah.
That's it. So when I do this complex fraction, I get 2x plus 13. Looks like there's an x in the front. And I'm sorry, I'm out of room here. 2x squared minus x minus 2. Yes or no? What you think?
Yes.
Easy?
What we were doing before, then now do that.
Yeah. This is kind of brings everything we've done with rationals together. This is the addition, subtraction, the multiplication, the division, and the simplification.
For me, I have to be careful with this.
Yes, for sure. That'll mess you up, for sure. Let's do another one. Let's do... I think the key to this is just taking it piece by piece, chunking it out like that. Over... So the directions just say simplify. Okay, so we're just going to simplify. Let's do top first. So I have 3x over 2x minus 1. And I'm going to put that 2 over 1 since it's just a whole number. So this is an easy fix here, finding the LCD. Because the bottom of the second one is 1. So what's the LCD here? 2x minus 1. So the first fraction's good. The second fraction needs 2x minus 1.
Can we do one of those?
Oh. Okay, so here's what I'm going to do. I'm going to take the top. And I'm going to go ahead and distribute this. So minus 2x plus 2 over 2x minus 1. Yes. Ah, you are correct. I'm sorry. Ben's distracting me. 3x and negative 4x. What?
What do you mean minus 2?
Well, you're distributing negative 2, so it becomes positive. All right, Ben. So I get negative x plus 2 over 2x minus 1. Okay, and I may decide, depending on how that bottom looks, to make this negative 1 times x minus 2 over 2x minus 1. We'll have to see what it looks like. 3x minus 4x. Yeah, that's a 4. When you do 2 times 2, I had originally put 2 because I was...
How did you get rid of the 3?
3x minus 4x is negative 1x.
Oh.
Hey, I put it in my...
Ben. Well, top, bottom together. So we did the top. So that's a third of it. So now the bottom... So I have 5 over 4x minus x over 2x minus 1. What is the LCD?
4x and 2x minus 1.
What's the first one need?
2x
minus 1. What's the second one need?
4x.
So I have 10x minus 5.
Wait, so you pretty much just do it twice?
I'm distributing, yep. Minus 4x squared over the LCD. Ah. So I'm going to maneuver this around a little bit so my leading coefficient is in front. And remember, we really, really, really don't want a negative leading coefficient.
Gotta negative it out of there.
Yes, even though that didn't make a lot of sense, but I know what you mean. Take a negative out of there.
Of course.
Negative 1.
Oh, wow. I don't know.
So change all those signs. Ah, why did I change that to 5?
Yeet.
I'm looking at the end of the equation there. All right, 10x It looks hard, but it's really not.
Wait, so pretty much is it just like the same thing we were just doing like on the
It really is hard.
Every single thing.
Say again, Ben.
It's just like, so we pretty much just find the LCD and get them all the same. Like,
We look at them as 3 different problems, yeah. We do the top, the bottom, then we put them
so
together.
it's very similar to the last thing we just did.
Yeah. It's everything put
Ah,
together,
yeah,
Ben.
hard,
It's
man.
everything put together. All right, looking at this, can you factor, does anything multiply to 20 but add to 10?
Yeah, wait, more like, yes. 5 and wait.
Anything multiply to 20 but add to 10? No. The answer to that is no. Let's put them together.
You haven't even put them together yet.
No. Sit down. Here and put them together because I'm out of room up there on my columns. All right, first one, top. I'm going to flip the bottom over, guys. 4x, 2x minus 1 over -1, 4x squared minus 10x plus 5. All my addition and subtractions are enclosed, so I can start canceling. Tell me what cancels. 2x minus 1. Nice. Anything else? -1. I definitely cancel that out. That looks like it. So now I just write it. 4x, x minus 2 over 4x squared minus 10x